Law of sines. Our objective is to use the law of sines to solve triangles. With the law of sines, it allows us to solve for triangles where they're not right triangles anymore. So who uses this? Engineers can use the law of sines to solve construction problems. Before we start, why don't we practice putting some of these larger numbers into our calculator? So, use a calculator to find each trigonometric ratio. Round to the nearest hundredth. So take a moment and insert each of these into your calculator and see what you get. Now that you've had a moment to insert each of these into your calculator, see if these are the answers you got. So the sine of 135 is 0.71. Tangent of 98 is 7.12. Cosine of 108 is negative 0.31. The tangent of 175 is negative 0.09. The cosine of 92 is negative 0.03. And the sine of 160 is 0.34. Notice these numbers are a bit different than what you were getting in the last few sections. Let's look at the theorem for the law of sines. For any triangle ABC with side lengths little a, little b, and little c, this is basically the ratio that happens. So the sine of your angle over the side opposite it equals the sine of another angle over the side opposite of it. So you're playing with opposite angles and opposite sides. You can use the law of sines when you have two angle measures and any side length, or two side lengths and a not included angle measure. So if you have something like angle side angle, or angle angle side, or if you've got side side angle, that's when you can use the law of sines. If you don't have one of these, you'll learn in a later section about the law of cosines. Let's try practicing. So we'll do the first couple together, and then you guys will try the next ones on your own. So, using the law of sines, we want to find the length of DF. So let's highlight our DF so we can make sure that we get the right side here. So we want to find this length here. So, now it's time to solve. We have an angle and its opposite side, an angle and its opposite side. We also have what we have is angle, angle, and a side. So, once again, we play with opposites. So we need the sine of 105 over the side opposite of it, so that's over 18, equals the sine of 32 degrees over the side opposite of it. So now we can just simply solve for x. In this case, we're going to cross multiply. So we have x times the sine of 105 equals our sine of 32 times 18. So then when we simplify this up, we multiply the sine of 32 times 18, and we get 9.5. And so x times the sine of 105 gives us 9.5. So therefore x is about 9.8. So the length of DF is 9.8. Let's try the next one. In this case, we want to find an angle measure. So we're looking for the angle measure of S. So, once again, play with things that are opposite. So, opposite side, opposite angles. So we want the sine of angle S here. And the side opposite our angle S is 5 equals, and then we have the sine of 75, and the side opposite of that would be 7. So we can cross multiply. So we have 5 times the sine of 75, which is 4.8. And then we have 7 times the sine of s. And we don't know what the sine of s is yet. So we can divide both sides by 7. And we end up with 0.69 equals the sine of s. Now, we're trying to find an angle measure. So if you recall back, this would be when we would use the inverse. So the sine inverse of 0.69 will give us our angle S measure. In this case, it is 44 degrees. So the measure of angle S is 44 degrees. Try these next two on your own. Now that you've had a moment to try these next two on your own, let's see how you did. So we have 39 degrees and 22. We're looking for NP. So we can highlight our NP here. Make sure we find the correct side. So we can do the sine of 88 degrees over our unknown, which is NP, equals our sine of 39 degrees over our opposite side of 22. We can cross multiply, so the sine of 88 times 22 is 21.99, and that equals our x times the sine of 39. To solve for x, we're going to divide by the sine of 39. And we end up with x is about equal to 34.9. So NP is 34.9. Let's look at the measure of angle L. So we have the sine of L. The side opposite of L is 6. And we have the sine of 125. And the side opposite this angle is 10. So we can cross multiply. So we can do 6 times sine of 125, and then 10 times the sine of L. So 6 times the sine of 125 divided by this 10 will give you 0.49 equals whatever our sine of L happens to be. And then we can use sine inverse of 0.49, and we will get about 29 degrees. So the measure of angle L is about 29 degrees. And that concludes our lesson on the law of sines.